Imagine a computer so powerful, it could solve in seconds what would take today's supercomputers thousands of years. Now imagine it doesn't think in zeros and ones like your laptop, but in a strange, magical language of quantum physics. Sounds confusing? It's not, at least not today. In this video, I will explain what quantum computing is, how it's different from normal computers, and why everyone from Google to NASA is racing to build one. No jargon. No physics PhD needed. Just the clearest explanation you've ever heard. Let's make quantum computing make sense. Let's start with what you already know. Your phone, your laptop, even this video, all powered by classical computers. They use bits, the smallest unit of data. A bit is either a 0 or a 1. Everything digital, from photos to video games, is built from billions of these bits. These classical computers follow strict rules, one step at a time, one possibility at a time. But some problems are too complex or too massive for even our best machines. That is where quantum computing comes in. Quantum computers use qubits instead of bits. And here's where it gets cool. A qubit can be a 0, a 1, or both at the same time. This is called superposition, like flipping a coin that's both heads and tails until you catch it. Now add in another weird quantum rule, entanglement. It means qubits can be linked, so that changing one instantly affects the other, no matter how far apart they are. Together, these properties allow quantum computers to explore millions of possibilities at once, not one by one like classical computers. It's like comparing a candle to the sun in terms of computing power. Quantum computers aren't just faster, they are built for completely different problems. They could help discover new medicines by simulating molecules, optimize global supply chains, predict climate models with insane precision, break or build unbreakable encryption, solve math problems too complex for any existing computer, but they're not good for everything. You won't be browsing Instagram on a quantum iPhone. Instead, they'll be used for specific problems where classical computing hits a wall. Yes and no. Quantum computers exist, but they are still in their early stages. Companies like IBM, Google, and Microsoft are building them, but the machines are fragile, expensive, and need near absolute zero temperatures to operate. In 2019, Google claimed quantum supremacy, meaning their quantum computer solved a problem no classical computer could, even if it was a highly specific task. So we're not quite in the age of quantum computing yet, but we're definitely on the way. So, what is quantum computing? It's not just a faster computer. It's a whole new way of thinking, powered by the strange rules of the quantum world. From solving climate change to cracking codes, it could transform the future, once we figure out how to tame it. If you want to understand how quantum AI could reshape our world, don't forget to like, subscribe, and comment what tech you want explained next. The future is quantum. And it starts with understanding it today.